Hi, I am Sanjay Patel. Today we are going to start the topic of convergence and divergence of infinite series from our calculus course. For this, we have to understand some basic concepts from sequences and limit of sequence. So let us understand what is sequence and some fundamentals. So sequence, first of all, we understand what is the meaning of a sequence mathematically. Suppose if I write some numbers like this, say 4, 7, 10, 13, 16 and so on, then such numbers are written in this way is referred to as a sequence. We can understand this 4 is written first, so this can be treated as the first term of the sequence. So we can call this as the first term of the sequence. This we can call as the second term of the sequence, third term, fourth term and so on. Okay, so one can think this way that there is a relation or a functional relation between two sets. One is the set of natural numbers here, which is written in the first line, these numbers 1 2 3 4 and so on, and another set is the set A, which contains the terms of this sequence. So one can think of a function from the set n to the set of the given numbers. Say it can be any set. If you have a 1 2 3 over here, say 1 2 3 4 and so on in the set of natural numbers, then in our example this 1 is related to 4, 2 is related to 7, 3 goes to say 10 and so on. So there is a function from n to a, and this function f is called a sequence. So sequence mathematically is defined as any function whose domain is the set of natural numbers. Okay, and this 4, 7, 10, etc., they are called terms of the sequence. So we may call it by some name or symbol. Say this is denoted by say a1, the first term, this is second term, the third term and so on. So the natural number n goes to some value, say an. Okay, so let us define what is a sequence. Any function, a function whose domain is the set of natural numbers n, okay, is called a sequence. So this is the most important thing. Any function whose domain is the set of natural numbers is called a sequence. So I can also write this way: if f is any function from n to a is a function, then f is known as, or f is called a sequence. F is called a sequence, and it is called sequence in A, or it is also known as progression, or it is called progression in A. So this f is a sequence in A. According to the set A, the sequence is called the sequence of integers or sequence of real numbers, like that. So if A is equal to say z, then f is called real sequence. F is called integer sequence or sequence of integers. If A is equal to say r, the set of real numbers, then f is called real sequence, or sequence of real numbers. So likewise, depends on the codomain. If codomain is Q, it is called sequence of rational numbers and so on. So if f is a function or a sequence from n to a, then we can write like this, or we can denote it like this: if f from n to a is a sequence, then we have we have f of n for every element in the domain, say small n belongs to capital N, we have f of n, some value in a, and that value we may denote by an or say tn or any symbol you like, or sn. Okay, so the notation for the sequence is denoted by, therefore the sequence is denoted by the symbol curly bracket f of n, or we can write say an, or we can write tn, and so on. Okay, so there are different notations you can use. So this is about sequence. This an is called the nth term. This is called the nth term of the sequence, or a general term of the sequence, nth term of the sequence. Okay, so for example, suppose I have function f from say n to z like this. Fn is equal to minus 1 raised to n. Okay, then I have f of 1 is minus 1, f of 2 is minus 1 square, that is plus 1, f of 3 is minus 1 cube, that is minus 1, and so on. So it is clear that we have a sequence of these terms. So here an is minus 1 raised to n. So we can denote this sequence in this way, minus 1 raised to n into curly bracket. Let us recall the basic and the most fundamental class of different types of sequences. Like, you have studied arithmetic sequence, geometric sequence, harmonic sequence, and so on. So we'll just write the basic things about these three types of sequences which are important to us. The first one is arithmetic sequence. Arithmetic sequence. It is also called arithmetic progression. So we may write A dot P, arithmetic progression. A sequence for which the difference between two consecutive terms remains constant is called an arithmetic sequence. And if the first term of the arithmetic sequence is A and there is a common difference, as say the difference between two consecutive terms is D, then we can write that arithmetic sequence as A plus D, A plus 2D, and so on. A plus say n minus 1 into D, and so on. So this type of sequence is called arithmetic sequence. So the difference between any two consecutive terms is constant, and the difference is always taken in this manner: any term minus the previous term. Like here, A plus 2D minus the previous term is A plus D gives you D. So the common difference is D, A is the first term. So the general term or the nth term of this arithmetic sequence is given by an is equal to A plus n minus 1 into D, okay, for every n belongs to n. So this is the formula, or you can say nth term of arithmetic sequence. For example, you have many examples you can take, and this is also very important thing, like say this 2, 4, 6, 8, this is a sequence of even numbers. It is also an arithmetic sequence or arithmetic progression, because the difference between any two consecutive terms is constant, and that is 2. Let us take another example. Suppose if I give you a sequence like this, the first term is say 3, then 7, 11, 15, 19, and so on. Consider this sequence. Now if you check the difference between two consecutive terms, so 7 minus 3, this difference is 4, 11 minus 7, that is also 4, 15 minus 11 is also 4. Likewise, here if you observe the difference between any two consecutive terms is 4, that is called common difference, and we denote it by D. So D is equal to 4 here, and the first term here A is equal to 3. So therefore you can write the nth term of this sequence an as A plus n minus 1 into D using this formula, that is 3 plus n minus 1 into d, that is 4. Okay, so the simplification will be, say, 4n. Okay, 4n minus 4 plus 3, that is 4n minus 1. So this is the nth term of the sequence. So we may write this sequence as 4n minus 1. Okay, but instead of using this formula, it is useful to understand another direct way of writing the nth term for an arithmetic sequence. Like here, the first term is 3, the first term is 3, and the common difference is 4. So whenever you have an arithmetic sequence, first of all, find out the common difference. Like in this case, it is 4. So what I will do is, I will write 4 and multiply it by the natural number variable, say n. Now, we put n equal to 1 in this. We put n is equal to 1 in this and see what we are getting. Putting n is equal to 1 here, we get 4 into 1, that is 4. But for n equal to 1 means I want the first term here. The first term is 3 and what I am getting is 4. So to adjust, I should subtract 1. So 4n minus 1 gives you the first term properly, and this is the direct formula what we have derived by using the given formula for arithmetic sequence. So this is the direct way of writing the nth term. Okay, so what is en here? En is equal to 4n minus 1. Let us take another example. Suppose we have another sequence, say 2, then let me write some other thing, say 5, then 8, 11, 14, 17 and so on. Here note that the difference between two consecutive terms is 3. 8 minus 5 is 3, 11 minus 8 is also 3 and so on. So if you want to write the nth term directly, you can write an is equal to, first the common difference is 3, that you multiply with n, so 3 into n. Now put n equal to 1 here, so a1, that is 3 into 1, that is 3 only, but we want 5 as the first term. So we should add 2 to this, and this becomes our nth term formula or the general term of the sequence given here. So this sequence you can write as 3n plus 2. Okay, so this is about arithmetic sequence. And if you have n terms of arithmetic sequence, we have a formula to find the sum also. So that is also an important thing. Just remember, if we have an as an arithmetic sequence, so an is equal to a plus n minus 1 into d is some arithmetic sequence where the first term is a and common difference is d. Then the sum of the first n terms, this is first term, then the second term is a plus d, third term is a plus 2d, then fourth term a plus 3d, and so on. The nth term is a plus n minus 1 into d. So this is a1, a2, a3, a4 up to an. The sum of all this is given by n by 2 into 2a plus n minus 1 into d. And this sum can also be denoted by a symbol Sn. So Sn is the sum of the first n terms of an arithmetic progression or arithmetic sequence. So this may be also some useful thing. Second type of sequence we are discussing is a geometric sequence. Okay. So second thing is a geometric sequence. Geometric sequence. It is also called geometric progression. Okay. A sequence for which the ratio between the two consecutive terms remains a non-zero constant is called a geometric sequence. For example, suppose if I write a sequence like this, say first term is 2, then 6, then 18, and so on. Then if you take the ratio here, the ratio is taken like this, 6 by 2, that is 3, then 18 by 6, that is also 3, and so on. So this 3 is called a common ratio, and it is always denoted by the symbol R. It is known as common ratio. And such a sequence is called geometric sequence. So what is a geometric sequence? A sequence in which the ratio between two consecutive terms remains non-zero constant is called a geometric sequence. Here this 2 is the first term, which we always denote by small a, and then in this case the nth term, or let me write down different terms of a geometric sequence. Suppose a is the first term, of geometric sequence, and R is the common ratio, which is not 0. Then the geometric sequence is given by, or a geometric progression is given by a first term, second term is a into r, third term is a into r square, fourth term is a into r cube, and so on. So nth term is a into r raised to 1 less. So this is first term, second term, third term we have 2 here, fourth term we have 3 here. So for nth term we have r raised to n minus 1, and so on. So such a sequence is called a geometric sequence. So the general term of geometric sequence is, or the nth term is a into r raised to n minus 1, where a is the first term of the geometric sequence and r is the common ratio. Okay, this is also a geometric sequence. For example, we have this 1 by 2, then say 1 by 4, then 1 by 8, 1 by 16, and so on. So if I take a ratio here, 1 by 4 upon 1 by 2, okay, so that is 1 by 2. If I take 1 by 8, these two terms, 1 by 8 divided by 1 by 4, it is also 1 by 2, and so on. So this is a geometric sequence where the common ratio R is 1 by 2. The first term is also 1 by 2. So the nth term formula is given by an is equal to a into r raised to n minus 1. Using this, a is 1 by 2 into r raised to n minus 1. That is 1 by 2 raised to n minus 1. Okay, so this gives you an is equal to 1 by 2 raised to n. Okay, so this is the general term of this sequence. So I can also write this sequence in this way: 1 by 2 raised to n, or 1 upon 2 raised to n. This is the nth term or general term of this geometric sequence. We also have a formula to find the sum of the first n terms of a geometric sequence, and it is given by this thing. So another important thing to remember is the sum of the first n terms of a geometric sequence or a geometric progression, okay, with first term is say a, and the common ratio is r, is given by say Sn, that is a plus ar plus ar square up to a into r raised to n minus 1. This sum is given by this formula. Let us write it systematically. This formula is this way. It is a into 1 minus r raised to n upon 1 minus r if r is not equal to 1. Okay, if r is equal to 1, then this formula is undefined, because there is a 0 in the denominator. In that case, means if the ratio is 1, we cannot use this formula. But if the ratio is 1, we can directly put r equal to 1 here and see a plus a and so on. We'll get n times a. So the answer will be NA. So NA if r is equal to 1. So when the ratio, the common ratio of a geometric sequence is 1, then sum of the first n terms is given by n times a, where a is the first term of the geometric sequence. So this is also a very, very important formula. This Sn means the sum of these first n terms. Okay. You also know the sigma notation, which is very, very useful. Like if we have a1, a2, a3, then a1, a2, a3, and so on up to say n, then this summation we can denote by this notation sigma ai, I is equal to 1 to n. Okay, like this. We can also write say am plus 1 plus am plus 2. If you start with any number as a subscript and go up to some number, say n, then we may write this as sigma k is equal to m to n, say ak. Okay, where m and n are natural numbers and obviously m is less than n. Okay, so these are all useful notations, and you know properties of sigma also, this summation notation. What is next is want to explain the third thing, that is harmonic progression or harmonic sequence. Harmonic sequence or harmonic progression. Okay. A sequence is said to be harmonic if the sequence formed by taking the reciprocal of that sequence is an arithmetic sequence. Means a sequence, let me write this way, a sequence an is said to be harmonic, sequence if the sequence of reciprocals of this an, that is if the sequence 1 upon an, this sequence is an arithmetic sequence, Here you note that for harmonic sequence we need all the terms to be non-zero. There should not be any zero term in the given sequence, otherwise the reciprocal is not defined. So all the terms of harmonic sequence are non-zero. Okay, so that is important. And for example, let me give you one simple example of harmonic sequence. That is, say if we have this sequence, say 1 upon 3, 1 upon 5, 1 upon 7, 1 upon 9, and so on. So suppose this is the given sequence, then it's a reciprocal sequence. The reciprocal sequence is given by, say reciprocal of 1 upon 3 is 3, then 5, then 7, then 9, and so on. So this is an arithmetic sequence or arithmetic progression. Therefore, this is harmonic sequence or harmonic progression. Okay, so harmonic sequence is defined like this. So the next, we want to understand some special class of sequences. The first important definition I want to explain is a definition of a bounded sequence. Definition of bounded sequence. Term is very simple. A sequence an of real numbers is said to be bounded, is said to be a bounded sequence, if there exists some real number k greater than 0 such that mod of an is less than or equal to k for every n is equal to 1, 2, 3, and so on. One can also define this bounded sequence as, or if there exists, instead of this condition we can replace it by this condition, say if there is some real numbers p and q, say p and q in R such that p is less than or equal to, say, an is less than or equal to q for every n belongs to n, then the sequence an is said to be a bounded sequence. For example, we have this sequence, say, consider the sequence an is equal to 1 upon n. It is also a very, very important sequence. An is equal to 1 upon n. The terms of the sequence 1 upon n are 1, 1 by 2, 1 by 3, 1 by 4, and so on. So you can understand that all the terms are positive and they lies between 0 and 1. Okay, so the terms will be like this: 1, 1 by 2, then 1 by 3, then 1 by 4, and so on. So sequence is going near to 0 in this case. All the terms of this sequence are approaching the number 0 in this case. So here this sequence is bounded because all terms are lying between the two numbers. I can say it is clear that 0 is less than an is less than or equal to 1 for every n belongs to n. So this is p and this is q. So we have found two numbers p and q such that p less than or equal to an less than or equal to 1. Okay, or one can also write in a different way, or I can say mod an is less than something. So I can take any number, I can take 1 or 2, something like that. So 2, mod an is less than or equal to 2 for every n belongs to n. Because all values, maximum value of this sequence terms is 1, then it keeps on decreasing. Okay, the first value is 1, then it is 0.5, then 0.33, and so on. Then this is 1 upon 4 means 0.25. So the value of the terms of this sequence keep on decreasing. Such a sequence is also called a decreasing sequence. What we are interested here is a bounded sequence. There can be, say, a sequence which can be bounded only one side and not bounded on the other side, like it is bounded above but not bounded below. For example, if I give you a sequence, say, consider a sequence, say, n square, or say simply n, or n square. What is n square? That is sum of the squares, n square means all perfect squares. So 1, then 4, if you put n equal to 4, then 9, then 16, 25, and so on. You can see that these values of the terms keeps on increasing indefinitely. Okay, but it will not keep on decreasing here on this side. So I can say that all terms of this sequence, that is are greater than or equal to 1, or I can say 1 is less than or equal to an for every n belongs to n. So this sequence is known as a bounded below sequence. Such a sequence is called bounded below. Means it has a lower bound, but it does not have any upper bound. Here this sequence 1 upon n has both lower bound and upper bound. 0 is the lower bound of this sequence, 1 is an upper bound of this sequence. Here this has lower bound but no upper bound. We can have a sequence which is bounded above but not bounded below. For example, let us take this sequence, say minus n. Then for this sequence, we have the elements say minus 1, minus 2, minus 3, and so on. So it is clear that these terms are keep on decreasing. So I can write that all the terms of this sequence, say if I call it an or tn, whatever, an is always say less than or equal to minus 1. But there is no lower bound here because these terms are decreasing indefinitely. So this is true for every n belongs to n. So such a condition is called bounded above. So this sequence is bounded above. It is bounded above by the number -1. So it is bounded above but not bounded below, while this sequence is bounded below by 1, but it is not bounded above. Means it has no upper bound, but it has a lower bound. While this has upper bound, but no lower bound. A sequence which has both upper bound and lower bound, that is a sequence which is both bounded above and bounded below, is called a bounded sequence. Like 1 upon n is a bounded sequence. Okay, so this type of sequences are very, very important. Another important concept I want to explain is the concept of increasing and decreasing sequence. So let me write a definition of increasing and decreasing sequence. Let an be a sequence of real numbers. Let an be a sequence of real numbers. Or I can also say that let an be a sequence in R. Okay. Then the first thing, if we have this situation, an is less than or equal to an plus 1 for every n belongs to n. That is we can say a1 is less than or equal to a2. If you put n equal to 1 here, a1 and this becomes a2. Then for n is equal to 2, you will get a2 less than or equal to a3. So if we have this situation, then such a sequence is called simple increasing sequence. Then if it is true for every n, then an is said to be increasing sequence. Is said to be an increasing sequence. Increasing sequence. And we write up arrow symbol for increasing sequence just for convenience. The other way, if we have an greater than or equal to an plus 1 for every n belongs to n, that is we have this situation that a1 is greater than or equal to a2, a2 is greater than or equal to a3, and so on. So first term is the biggest term and all other terms keeps on decreasing. In such a case, we call an to be a decreasing sequence. So then an is said to be a decreasing sequence. Is said to be a decreasing sequence, and we write the down arrow for decreasing sequence. So these two are very important class of sequences, increasing sequence and decreasing sequence. If a sequence is either increasing or decreasing, it is said to be a monotonic sequence. So the third thing is, if an is either increasing, an is either increasing or decreasing, then it is said to be, an is called a monotonic sequence. An is called a monotonic sequence. It's called monotonic sequence. So another important term that you can remember, what is a monotonic sequence? A sequence which is either increasing or decreasing. Okay. And if we have strict inequality in these three definitions, it is called strictly increasing or strictly decreasing or strictly monotonic sequence. So if an is strictly less than an plus 1, then it is called strictly increasing sequence. So we can have two more definitions here, like just I will write the word strictly increasing sequence, and strictly decreasing sequence. Strictly decreasing sequence. If we have a1 less than a2 less than a3 like this, then such a sequence is called strictly decreasing. We can also write this condition, an is less than an plus 1. For decreasing sequence, if you have A1 greater than A2 greater than A3 and so on, or equivalently you can say An is strictly greater than An plus 1. So this is about increasing and decreasing sequence. So we have studied two important concepts here. One is bounded sequence and other is monotonic sequence. If a sequence is either strictly increasing or strictly decreasing, it is said to be strictly monotonic sequence. Say some simple example of this. For example, if you consider the sequence 1 upon n is strictly decreasing sequence. Strictly decreasing sequence. Because 1 is greater than 1 upon 2, 1 upon 2 is greater than 1 upon 3 and so on. These are the different terms of this sequence, as you know, and it keeps on decreasing, and we have this sign. So I can say An is strictly greater than An plus 1 because we know that n is strictly less than n plus 1. So I can take reciprocal and get 1 upon n is greater than 1 upon n plus 1. But 1 upon n is nth term, that is An, and 1 upon n plus 1 is n plus 1th term. So we can also prove this way logically that this sequence 1 upon n is strictly decreasing sequence. Okay. Then another example we want to consider here is strictly increasing sequence. For example, if I have say 2n plus 1 or 2n plus 3, then the terms of this sequence are, say if you put n equal to 1, you will get 5. For n equal to 2, 2 to the 4 plus 3, that is 7, then 9, then 11 and so on. So you can see that these values goes on increasing, so it is increasing sequence. Mathematically, we can prove this way. If you take two consecutive terms, say an and an plus 1, so an is 2n plus 1 and an plus 1 is 2 times n plus 1 plus 3. Let us understand this way. If you have, say, n and n plus 1 for any natural number n, then I can write n is less than n plus 1. Okay, n is less than n plus 1. So that is one thing. And let us multiply by 2 on both the sides. So 2 into n is less than 2 into n plus 1. Now adding 3 on both the sides, so we'll get 2n plus 3 is less than 2 times n plus 1 plus 3. So I can say this an is strictly less than an plus 1. And this is true for every n belongs to n. So this is strictly increasing sequence. It is called strictly increasing sequence. Okay. Now, after having some basic knowledge and basic concepts about sequences, in our next video, we are going to discuss what is the meaning of limit of a sequence. And we'll also mention some useful formula to find a limit of some special sequences. And then after the second video, we are going to start our actual topic, that is convergence and divergence of series.